sample forms the lid. Sample forms the lid, and the direction of permeation is from the outside to the inside. And so in one method, as the procedure progresses, the weight of the cup decreases because the water evaporates, the water vapor passes through the specimen, and it goes out into the environment of the chamber. And so over time, the amount of water in the cup will reduce, the weight of the cup assembly with the specimen decreases. And so we're looking at measuring a weight decrease. In the desiccant method, the reverse is true. So we have high humidity on the outside going into the low humidity atmosphere inside the cup where the water vapor is absorbed by the desiccant. And in doing so, the weight of the assembly increases as the desiccant absorbs the water vapor. So in the method, we are measuring a weight gain. The whole assembly gains weight as more and more water vapor is absorbed by the desiccant. So the components of a system or apparatus for performing these tests consist of some kind of test dish, could be call it a dish or a cup, a chamber in which to place the dishes with the specimens mounted, and inside the chamber is a temperature and humidity controlled environment. And then we need some way of weighing accurately the small changes in weight that are experienced as the water evaporates or the desiccant increases in weight. And then finally, we need a thickness measurement gauge to measure the thickness of the material accurately, and some distilled water or some desiccant. So these are the fundamental components of an ASTM E96 test system. So manual test devices, you need the oven, of course. Some of the ovens, some laboratories may already have those kind of things, for example, for accelerated aging or other uses for an oven like that. You need some cups and you need a laboratory grade scale. And for the automatic test system, we have a test cup or test dishes again. There is a method of handling the cups, which is automatic, some method of control, and a weighing cell. So we've taken all these distinct components of a system and we've incorporated them into a simple to use automated test system. So let's take a look at some of the advantages that gravimetric measurement can offer. So one of the most important things about this method is the first point here. This is a directly obtained result. There is no sensor which is going to calculate light transmission through an infrared sensor or some kind of electrochemical reaction which is going to be converted into a measurement of the amount of water vapor molecules passing the center. This is a directly obtained measurement. So we're measuring directly weight gain or loss. So this is important. The high stability of the test results. If any of you have been familiar with ASTM E96, you'll know that when you do the test manually, it can take several days, and we are concerned with the measurement and changes in weight over a long period of time to get accurate and stable results. And the last point is that because this is a directly obtained result, if there is ever a situation whereby you or a customer or a supplier is presenting data obtained by perhaps an infrared sensor method or electrochemical electrolytic sensor method, and there is a disagreement on whether the accuracy of those results when they're compared with other results, then this method is referred to as an arbitration method. That is to say that because it's a direct measurement method, this method is used to have the final word, if you like. So if ever there is a a distinction between two sets of results and a disagreement as to whether those results are accurate or not, you can use ASTM E96 or gravimetric measurement method to be the determining method. And part of the traceability of the method relates to the use of reference test specimens. So we can use reference films with this method for which we know what the transmission rate is under a given set of temperature and humidity conditions. We can use those reference films to verify that the machine or the method is working accurately. And in that way, you can use ASTM E96 as a verification method or a validation method, or if you like, an arbitration method. So sometimes there's some misconception about E96 that it's only suitable for very permeable materials, like paper and board, or things like spun polyolefins or materials which are used for house wrap and such like, which are designed to be waterproof but breathable. Well, advances in the technology and the accuracy of balances, the availability of sophisticated software to analyze results and such like has made this a method now with our automated equipment where we can confidently say that its applications are okay for a wide range of materials with transmission rates from as little as 0.01 up to 10,000 grams per meter squared per 24 hours per atmosphere. In practice, if you're searching for methods which will be ultimately the most accurate or the most sensitive for measuring high barrier materials, there are other methods available which will give you another degree of sensitivity. But it's fair to say that the range offered by ASTM E96 is one of its major attractions, in that you can test a wide variety of materials, not only variety due to their physical makeup, but also to variety to their barrier materials. And the humidity range achievable is between 10 and 90% plus or minus 1%, and a temperature range of around 15 or 20 Celsius up to 55. So to reiterate, papers, plastic films, textiles, this is a popular one. Companies which are making outdoor clothing where the clothing is designed to keep the user dry, so waterproof, but also it needs to be breathable so that the person wearing the clothing is not uncomfortable to a high humidity and high temperature inside the clothing. Fiber boards, plaster for building applications, wood flooring is another one, and all kinds of other building materials and coatings. So there are some advantages for working with the gravimetric methods. As I mentioned, you can refer to it as an arbitration or definitive method. There's no limit to the amount of cups or dishes that you can put into an oven. You're only limited by the size of the oven. In the case of our automated equipment, we have instruments which can measure WVTR in 3 test dishes or cups up to 6, and further up to 12 samples. There's a lower consumption of materials. For example, we don't need any carrier gas, so it's less expensive to use ASTM E96 than it would be to use infrared or electrolytic methods. Maintenance cost is lower. There's no expensive sensor involved. So infrared sensors and electrochemical sensors are expensive, several $1,000s to replace them when they come to end of life. There is nothing like that in a E96 system. We're using either a analytical balance if you're doing it manually in the lab, or if you're using one of our instruments, there is a very sensitive load cell which takes the measurements. And so it's environmentally friendly. That we're not in the construction of the instrument, it's not using very precious metals or anything like that. It's very, very simple to configure, and there's no unnecessary use of gas. It also has a lower energy cost.
Martin, you are muted. Yeah, Martin, you are muted.
Sorry, I wasn't. I hope I wasn't muted right from the beginning, was I?
Yeah. Start the slide description from the onset.
Okay. Well, I'm sorry about that. I unmuted at the beginning. It must have gone back over. I'm not sure what happened. Anyway, let's look at the test principle for the fully automatic test. So we have a test cup, the weighing system, the lifting system, the control system, all parts of the automatic system. And by the control system, this controls the handling of the cups and the measurements, so that periodically weighs each of the cups, auto zeros before each weighing, and ensures accurate data by doing so. So it takes away the scope for manual errors. One of the biggest issues with performing the test manually is that you have to handle the dishes very carefully. So for example, if we were using a test dish doing the wet method, if any of the contents of the dish splash onto the specimen, that really cancels the whole of the test. And so you might be several days into the test, have already done several weighings and recorded them. Then an accident occurs, somebody splashes some of the contents of the dish onto the specimen, the whole test has to be cancelled and you'd need to start all over again. And so by using an automated system like this, it virtually eliminates the scope for any kind of human error. And in doing so, that increases the repeatability and the trustworthiness, if you like, the reliability of the measurements that you take using this system. It's high accuracy, as I said, with advances in the technology and the improvements in the measurement devices that are available, we can say that the lower limit is 0.01 grams per meter squared per day. The balance is 0.1 milligram up to 200 Mettler-Toledo balance, sometimes with heavy or very permeable specimens, the capacity of the scale can be increased. Temperature range, the control range of the chambers incorporated with the instrument is between 20 and 55 Celsius plus or minus 0.2, with a humidity range of 10 to 90% plus or minus 1%. It's very efficient, multiple test cups, 3, 6 or 12 cups are options available. This means that you can test, for example, 4 sets of triplicates in one pass, in one machine. We advise you that although you can use different materials and mix them up inside the machine, it's better to try and keep the barrier properties of the material somewhat similar. So for example, you wouldn't want to test a very high barrier material at the same time that you're trying to test a very low barrier material. So try and keep them the same into the same groups, high barrier, medium barrier, or low barrier materials. All of the machines have different test modes. There is an expert mode and a fast mode. The fast mode is pretty much fully automatic. There's no need to set up any additional parameters or anything once you've identified the temperature and humidity of the test and started the test. It's fully automatic. The machine has different ways of terminating the test. One of the most popular and easiest to use methods is to use what we refer to as a proportional mode. and the proportional mode will terminate the test when the machine detects that 3 subsequent measurements are within a predetermined percentage of one another. So in other words, you would say, I'm happy with the results so long as they are within 5% of one another on 3 distinct weighings, and then the machine will stop the test automatically. You can decide if you want to monitor the test throughout and terminate the test when you decide whether the state of equilibrium has been reached. And lastly, you can terminate the test on a predetermined time. So if you're testing the same materials over and over again, perhaps in a quality assurance situation, and you know from experience that the test takes 48 hours or whatever, you can terminate the test on 48 hours. The great thing about using this automated equipment is that you don't require an operator to be in attendance all the time. And so it's feasible that you can start a test on, say, Friday afternoon or the day before the weekend, let the test run throughout the weekend, come in on Monday morning to work, go into the lab and look at the results, and the test may be finished. And so there was no need for somebody to be in attendance throughout the weekend to take periodic weighings by removing the dishes from a chamber, weighing them, recording the data and putting them back in again. It's fully automatic. And so the labor cost of performing the tests is minimal. It's really limited only to the preparation and mounting of the specimens. So I've alluded to this in what I've just told you about the efficiency of it. The equipment has very powerful software, which gives you a complete range of information and an overview of what's going on throughout the procedure. You can see in these examples, we've chosen to illustrate some screenshots from a 12-cup WVTR tester, so you can see the status of each individual cup. It's going to tell you which method you're using, what the temperature is. It monitors the humidity and adjusts it automatically. You can set a weighing interval. For example, you could set each cup to be weighed every 6 hours, and so on and so forth. So there's a lot of information that you can get from this because of the software, and you're not required to do any kind of manual calculations whatsoever. The components inside obviously are important because the accuracy of the system depends upon the accuracy of each of the individual components. And so we need to make sure that we use very top quality components for the load cell, for the humidity sensors, for the pneumatic connections, for the airflow measurement, etc., because all of these things add up to have a degree of error in them. They have a tolerance, and you add up the tolerances or the errors to get a stack of errors, and that's going to determine how accurate the end result is. And so it's very important to use very good quality, reliable components with very small, tight tolerances. So I said it was cost effective. Here are some examples using some data which we've collected from our own experience and from that of customers, comparing the manual method on the left and the automatic Labthink methods on the right. As I mentioned, the labor cost will be lower because the operator's involvement is virtually nil apart from preparing the specimens. And also the chamber and its control has been designed specifically for the number of specimens that will be used. So instead of having a very large chamber, which uses a lot of electricity, a lot of energy cost involved in running that chamber, the Labthink instruments have a very small energy demand, and so the cost is very minimal for using them, and also the cost of replacement parts and such like is very small. So quite potential cost saving at around 60%. And then there are different models for different applications. The C360 series can take 6 cups or 12 cups, has an accuracy of 0.01 for 10,000 grams per meter squared per day per atmosphere. W3062 has a capacity of 6 cups, slightly less sensitive than 360. And W3031 is a very basic instrument with 3 cups, which can only perform the wet method. The other 3 instruments, the 360s and the W3062, can perform both wet and desiccant methods. W3031 only performs the wet method or water method. So for different methods, you have different test ranges. If we look at the 360M, which is one of the more popular instruments, you can have 0.01 to 10,000 grams if you're using the water method, or 0.01 to 1,200 grams if you're using the desiccant method. The accuracies, as I said, they were 0.01, 0.01, 0.1, and 0.1. I'm not concerned with the resolution. It's a very high resolution. Temperature ranges are around 15 to 20 up to 55 Celsius, and then a range of adjustable humidity conditions. So in a second, I'm going to stop sharing and we're going to hand it over to Alex in our office in Frankfurt, Germany, who's going to show us around some of the instruments. To summarize, what I think is the most important takeaway from this is that this method provides a very simple way of deriving very accurate and repeatable WVTR measurements, compared to trying to do the test manually, where you have all the different components that you have to assemble. Great care must be taken in handling the dishes, as I mentioned. There is an enormous scope for human error when running the test manually. Virtually all of that scope of error is eliminated when you do the test with an automated system, such as one of the Labthink pieces. So I'm going to stop here and I'll stop sharing. My apologies if you didn't catch everything I said. I wasn't aware that somehow I'd lost the audio, but I hope you got the gist of what I'm saying, and I'd be happy to answer any questions when we get to the end. So Alex and George, it's over to you.
Thank you, Martin. Be sure that we missed not a single word from what you said, and it was a very interesting presentation. So I have to thank Martin Bryant, the Marketing and Sales Director of Labthink International. And now we're going to make a quick live demonstration of the 2 C360 gravimetric WVTR testers of Labthink. Alex Plop, the Technical Director of Labthink GmbH, the European subsidiary of Labthink, is going to guide us in those 2 very interesting testers. Alex, please.
Yes, thank you. Can you hear me?
Yes, Alex. Yes, I can hear you.
Yep. Okay, perfect. So, hi everyone. My name is Alex. Thank you very much for joining us today. I'm just gonna take a bit of your time to quickly show you the testers, how they look like, how we easily prepare the samples, how we install them, and then I will just stop my camera for a bit. I'm gonna move it in front of the screen so you can see how easy it is to actually input the parameters and immediately start the test. So I'm gonna quickly show you how we install the samples inside the cups. As you can see, these are how the cup is looking like. We have space here to put the distilled water or the desiccant or the molecular sieve. I'm gonna quickly show you how they look like. Obviously, this is not the correct way to store it, but for the demonstration purposes, this is fine. You can dry them to industrial oven. After we prepare the cups with the distilled water, if we use the water method or the desiccant or the molecular sieve, we actually use the desiccant method. We input them into our cups. We have prepared the Labthink reference film. In this case, I will just install it into my cup, and we seal it with this Teflon O-ring. It's going to look like this. I will take the cup, and initially I just close it with my hand. Of course, because I want to have a good closure of the cup, I'm going to use the special tools from Labthink that help me secure the cup in the most perfect way that I can do it. So I secure the cup into the holding tool, and with the guidances, I will just hand tight it, as we call it. And now my cup is prepared, and I can just easily install it into the 6-cup C360, which for us, it's the name of the model is C360M. Once everything is prepared, I just close the lid. This closes manually. And for the C60H, for which I have 12 cups, I will just use the software. I'm going to close the cover, and then I have an alarm that makes me careful that the lid is actually coming down, so I don't put my hands, so we don't injure the operator or everybody who's working with the tester itself. While the lid is closing, I'm going to tell you that the tester needs electricity, a stable workbench, and we need to have distilled water. Other than this, you don't need anything. So it's really straightforward to install. You just need to have a stable workbench to balance it, and you are ready to go. I'm just gonna, for a second, close the camera so we can switch to the software side. So please bear me a second. Okay, I will need your help. Can it be seen? Is it easily seen by everyone?
Okay, we
Yes,
can
Alex,
understand.
it's
We can
Oh,
understand, yes.
Perfect. So what I wanted to show you is that this is the main user interface. I have at all times the graphic representation of the cups. As you can see, and I was telling you before, we have 12 cups. Here on this lower side of the screen, we have the legend, which explains and shows me the color coding of the cups. Now, because all of them are gray, I can see that they are unused. For example, when they will be active, they will be with blue. And when your test will be over, they will be shown with green. The right side of the screen, I can see information of the current test that I'm using. So the standard that I'm using, in this case, is the ASTM E96. We have selected desiccant method, the test temperature that is 38 degrees Celsius, and the humidity 90% relative humidity. And now, as I was telling you, after I install the samples and the cups, I need to come to this parameter. And from here, I have the freedom to select whatever standard I want with desiccant or water method. And I have the freedom to actually input whatever temperature and relative humidity I want. And based on my selection, the test will perform this or not. As you can see, I have the confirmation of the software. Also, in the case that you don't have 12 cups, you don't have 12 samples, and you don't want to use them all, you can actually deselect the cups that you are not currently using. So you have the freedom of always using as many cups as you want. So if I want to select them, I can just select them all. Now, this would be the main parameters of all the cups, but also if I select cup number 1, here I have the freedom to input all the information that I want regarding my test. So here, all the spaces can be modified and filled up by the operator. For example, if we use the same type of material, the same sample in all the cups, you don't need to go to all the cups to input the information. You just input it for one, like I did, and I will just press sync other test cups. So this means that all the information that I have filled in cup 1, I can easily see them for all the cups that I have here. Once I am happy with my selection, I just click set parameters. I get out of the screen, and the only thing left to do would be to press start test. An important thing that I wanted to tell you is that in all the permeation Labthink testers, so also for this type, whatever test is being started will generate a report. So you don't have to worry what happens with your tests, with your data that you work to obtain. Please do not worry. For each and every cup, a report will be generated, and I can easily open one so I can show you. In the first part of the report, I can see all the information that we have input as operators, and then I have the graphs. So for example, we have the result here. So we have in grams exactly for this cup. I think it was cup 7. Also, if you don't like the PDF format, because this is the initial format that you save, you have the freedom to select to save it as an Excel or also Word format. And this will be all from my side. The software is very straightforward. Not only the initial interface, but also it has interesting features like operation logs. So anything that happens inside the software, including changing parameters or starting the test, it's being saved. Actually, I can show you this right now. The system settings. I have the operation log. So everything that has been done onto this test, it's being saved right here. This will help you or the managers or the administrator or the responsibles of the laboratory to understand what happens when they are not in the room. So what happens during tests or before the tests are being started. Also, you have the freedom of creating different users with different rights. So for example, if you have a student that does a practical stage, you will create a very limited user access for this kind of colleagues. Or if you have an engineer or an operator, you will create usernames according to them. We by default have 3 layers: technician, engineer, and admin. And I think these are the most important aspects of our our software. And thank you very much for following us.
Thank you very much, Alex. It was really nice and very descriptive. It's something we should refer to, that the gravimetric testers of Labthink are fully automated testers, easy to use. They have high accuracy and are testers of high reliability. And they offered also increased testing capacity with less operational costs. I think it is a considerable choice and an option that all laboratories should check. So after the show, the demonstration, it's time for your questions. The easy ones I'm going to answer myself, and the more difficult I'm going to forward to Martin Bryant and to Alex Plop, who are the specialists today. So I have from Mr. Ross Pieters a question. The tested area is the same in the 3-cup or 6-cup or 12-cup testing machine? Yes, the testing area is the same in all testers. Am I right, Martin?
Yes, George.
Okay, it was easy, but you never know. Thank you. I have a question from Mr. Dimitri Adons. Does the equipment correct the results with a blanco cup? So a cup without water or desiccant? Do we have a reply on this, Martin?
So the way that the machine is set up to accommodate this is that what you couldn't see when Alex was demonstrating it, because it's deeper inside the software, is that there is a section where you can set a calibration factor. And so effectively, to handle this situation, you'd set the correction factor so that you measure the dummy cup as if you were doing a test. And then you could set the correction factor by adjusting the calibration factor in the machine so that the dummy cup is treated as 0. And so that correction factor or calibration factor would then be applied to the results of all the cups that you tested. So you can't, the way it works is that you wouldn't be able to put in a dummy cup along with the other results. You're just going to get the result of the dummy cup. And I suppose you could say, well, okay, if I get the result of the dummy cup, I can just adjust the other results manually by taking into account what I got for the dummy cup. Or the other way to do it would be, as I say, would be to take a measurement of a dummy cup, and then you adjust the calibration factor of the machine to take account of that, so that correction factor would be applied to all the measurements of the other samples.
It was clear to me. I hope it was clear to Mr. Adams as well. Thank you, Martin. I have a question from Miss Julia Maxwell. Is it possible to set different test parameters for different samples that are run at the same time? Or are the test parameters set for the entire system? I think I can answer this. The test conditions, temperature and humidity, will be the same for the entire system. Also, the chosen standard, which we are going to use, and the method, if it is water or desiccant method, should be also the same. So from what I understand, the basic testing conditions and parameters are going to be set for the entire system. Am I right, Alex?
Yes, that's correct.
It's very correct. And I also came back to the testers, and I can show to them that it's one single incubator, and to also demonstrate and to make everyone understand why we will have only one set of parameters. So now the lid is slowly opening up. As you can see, we have one incubator here. So the temperature and the relative humidity will be all for all the cups. So all the cups
uniform
will be under the same conditions.
Okay, then I think this was answered. From Mr. Pierre Goepert, I have a question. Which material are the cups made of, Martin?
They're anodized aluminum, I believe. Alex, can you confirm that?
Yes, that is correct.
Okay, thank you very much. So anodized aluminum. Mr. Sergey Yudin has a question. Why do older devices have 400-gram scales and newer devices have only 200-gram scales? It is planned to check building material which are quite heavy themselves. So is it possible to install 400-gram scales in new C360 devices? I think, Martin, most probably you are the one to answer.
Yes, so the standard scale is a 200-gram scale, but depending on the customer's application, if it's determined that you need a larger capacity load cell in the weighing mechanism, that can be accommodated.
Okay, I hope it is answered, but Mr. Yudin, if you have specific questions with specialized needs, you can contact us directly and you can have a personalized reply. So I have now a question from Nabil. What about calibration of WVTR? Alex, do we need to calibrate a WVTR tester?
Yes, thank you for the question.
Gravimetric.
Of course, we need to calibrate it. We recommend the calibration to be done every 12 months. And the calibration, it's really straightforward, included with all the accessories. It is also weight, a 200 grams weight. We need to calibrate the scale, so we do a weight calibration, and also you need to run Labthink reference films to understand if everything runs smoothly. So yes, the calibration of the system must be done.
And I have also from Nabil an additional question. Is the precision same for the 3-cup tester and the 6 and 12-cup tester? So is the precision comparable for the W3 and the C360 testers? I think, Martin, you can have a good answer on this.
The newer ones, the C360, the lower limit of sensitivity is 0.01 grams. And for the W3 series, like the 62 and the 31, the lower limit of sensitivity is 0.1 of a gram. So there's a factor of 10 difference.
Okay. And another question from Nabil. The testing of samples happens in sequence or alternative? This I can answer. As you can see, the 6 or the 12 cups are on a carousel which rotates. So each sample is tested in sequence after the other. And after we complete one full round of testing, then we start the next round of testing, and on and on. So it is a sequence of testing, one after the other cup. I hope this is answered. Wouter Neely, we have an interesting question. Can this machine be placed in a standard lab, non-climatized? Yes, it can be. The internal incubator of the tester, as Alex Plop showed to you, is isolated and tested in such a manner that preserves the internal set conditions, temperature, and relative humidity. So unless you expose the tester in extreme conditions, which I don't expect to happen in a standard lab, the machine can stand alone in a non-climatized laboratory. Another question from Mr. Dimitri Adons. No, it is already answered, and he comes back to the question about the blank cup. So there is no report with the final values, WVTR cups minus WVTR dummy. Alex, what's your opinion on this?
So I think people need to understand what the system does after the test starts. The system first and tries and will obtain the parameters that we have set. Then the system does a pre-weighing of the cup. You can install, you have the freedom to install a dummy cup. It is not needed though. So the tester does a pre-weighing of each and every cup. And based on this initial measurement of each and every cup, the WVTR will be calculated again for each and every cup. So you will have it always at the end, only the measurement. You don't need to have a difference or a correlation between a dummy and another cup. So you can install one if you want, but it's not needed because the system does this pre-weighing.
Okay, thank you, Alex. Yeah, it's clear. It is optional. It is your choice to place one blank cup. The system will measure it, and you can use it, though manually, as a comparative how can I benchmark. So another, it's not a question from Mr. Soren Gag. Anyone who wants a video copy of today's webinar, he can contact me or Miss Lisa Zhang at info@labthinkeurope.com and get a copy. We'll be pleased to send over one. Again, Mr. Dimitri Adons has a question. When measuring in manual mode, what is the minimum WVTR measurable? I think since the test range goes up to 0.01, I think that we can test in a gravimetric WVTR tester of Labthink samples that are close or at the limit of 0.01 grams per square meter per day. And this is our recommendation. And a question about the repeatability of the accuracy. The accuracy is 0.01 grams per square meter. The resolution is 0.0001. So this gives us a high repeatability at the level of 0.001. So I think for measurements within the testing limit, we can have a high repeatability, and yes, you can repeat the accuracy. I have also a question from Emmanuel Boluvarin. Is it possible to share the presentation slide recordings? Yes, of course we can. I just answered to this. You have given your email. Our team will take care and forward it to you. Wouter and Healy, another question. What will be a possible delivery time of these machines? These testers are in startup production of Labthink, and I think we have in storage. If there are in storage after a final quality control, we can deliver within 1 or 2 weeks. In the unfortunate case that we are out of stock, it will take 3 to 4 weeks, so no more than 1 month. Nabil asks, how long reports will be registered and recalled? Alex, for how long can we have the reports stored in the tablet?
As long as you want. Actually, the tablet, it's a Windows tablet, so as big as the hard drive, the reports, as we know, it's a few kilobytes. There's not a problem with this. Mm-hmm. So as long as you want, even for 5 years.
Okay. I have a difficult question from Miss Julia Maxwell. Can you provide the price of each system that you have spoken about today? As a basic principle, we have committed that we're not going to refer to pricing during the webinar. We don't want to change the scope of today's event. But if you wish, Ms. Maxwell and anyone else who is interested on this, we can contact you and have a quotation forwarded to you. That's something we always do quickly and with pleasure. But thank you for asking. Ms. Daniela Neitske is asking, can you measure different conditions one after the other? Meaning, for example, 23 degrees, 50% relative humidity, and then 38 degrees and 90% relative humidity. Alex, can we do a set of testing at the first set of conditions and then another testing session in the different set of conditions?
Provided that you wait for the test to end, or you can also manually stop it. You can do this, of course. So after the test ends,
supposing that the test ends normally, supposing that
yes,
the first test,
you can immediately set the parameters, and then you can start another test.
So
I would not necessarily recommend this to be done, but you can do it. Yes, you have the freedom to do it.
Yeah. Okay. When measuring in manual mode, what is the minimum WVTR measurable? Sorry, Mr. Adams, sorry, it is already answered. And Mr. Rose Peters, your test equipment has USB outputs. Can we save the data on a USB stick and move the data to our computers? Alex, please.
Yes, so it's easily done. If you have a flash drive or a USB stick, you can connect it to the tablet, and then you can export a set of reports, or you can individually save them one by one with in 3 different formats: Word, Excel, and PDF. So yes, you can do this.
Okay, thank you. And I have a last question from Safwan Abu Saleh. Can we send polyamide film samples for testing to understand whether the equipment is suitable for your our production? Of course, you can send, and this is an answer addressed to all the participants who are interested on gravimetric WVTR testing method. We are open to our new testing laboratory in Frankfurt to receive your samples and test them in order to define whether the testers are appropriate for your samples, or if we should alternatively recommend other testers to be more suitable for your sample. So please feel free to send it to us. You can contact us via email, via phone, or just send it directly. You can find our German address in our website. Mr. Abu Saleh, I'm going to send you the contact in an email directly, and anyone else who wants. Yeah, thank you too. So since I don't see any other questions, I think we are covered for now. I have nothing more to do. I have something. Excuse me. No, okay, good. So I have to thank Martin Bryant for his thorough presentation and the rightful answers. I have to thank Alex Plop and the technical team here in Frankfurt for all the preparation job they did, and also Labthink instruments in China for the whole preparation and the infrastructure which were provided for this webinar to be realized. Finally, I have to thank all the participants in the webinar. Thank you for your patience. Thank you for your attention. And don't forget, Labthink is always at your disposal to offer you testing solutions for film and package testing. Of course, we are going to contact you for all our next webinars with interesting subjects. Have a nice day, and Labthink is always here for you. Thank you very much.
Thank you, George. Thanks, everybody.
Yeah.
Thank you all.
Everybody can leave the meeting room. Thank you.